6, lesson 7 is going to be focusing on solving inequalities by multiplication or division. So when we think about our objective for the day, we want to be able to, or I would like you guys to be able to solve inequalities by using either your multiplication or division property of inequality. And so we'll be taking a look at those two properties and what they mean. Okay? A couple of vocabulary words that you do have with this lesson: multiplication property of inequality and division property of inequality. So please make sure that you do get those filled in on your vocab web. We're going to go ahead and take a look at page 506 in your book to start off with. As you are looking on the top of page 506 in your book, you're going to see that it talks about your multiplication and division properties of inequality, and this is when we're working with positive numbers, okay? There is going to be a slight difference when you're working with positives and when you're working with negatives, so we want to make sure that we take a look and notice the difference between the two of them, okay? When we're thinking about our multiplication property of inequality, basically what that is going to mean is you are going to multiply both sides of your inequality by the same number. We had used the multiplication property of equality earlier in the chapter when we were working on solving equations, but today we're focusing on inequality. The division property of inequality, okay, is just like your division property of equality, except for the fact that we're working with inequalities. So because it's division, we're going to be dividing both sides of your equation by the same number. So let's go ahead and take a look at situations where you have positive numbers. Again, we're starting off with a basic inequality of 8x is less than or equal to 40. Let's think of it in terms of this. If we had 8x was equal to 40, what would we do to both sides? Well, in this situation, if it was an equation, we would divide both sides by 8. 8's cancel out, x would be equal to 40. Same type of concept. The only difference is here is instead of having an equation, we have an inequality. So we're still going to divide both sides by 8. Okay, so you can see in your book they've divided both sides by 8, and then 8's cancel out, x is left, x is going to be less than or equal to, and then the number would be 5 because 40 divided by 8 is 5. So your solution would be x is less than or equal to 5. Okay, so that's an example where we used the division property of inequality because we were dividing both sides by the same number. Example 2 gives you a situation where you have d divided by 2 is greater than 7. Okay, so again, if you think about this, if this was an equation, what would we do to both sides? We would multiply both sides by 2. Now, however, it's not an equation, it's an inequality, so we're still going to do the same thing in terms of multiplying both sides by 2. So you can see they multiplied both sides by 2. 2's are going to cancel out, d is left, d is going to be greater than, and then 7 times 2 is 14. What I would like to do right now is to take a look at a couple other examples real quick before we look at the got it problems that are on the bottom of the page. So one example could be maybe I have h divided by 4 is less than or equal to 3. Okay, again, start by finding your variable. Variable's being divided by 4. So the opposite of dividing is to multiply. So we're going to use the multiplication property of inequality and multiply both sides by 4. I know that 4 divided by 4 cancels out, it's 1. So h is left, h is less than or equal to 3 times 4 is 12. So there's my answer to that inequality. Okay, let's go ahead and take a look at another example. I have 5x is greater than 30. Okay, so again, we're looking at it in the same way we would as an equation. I'm going to find my variable. My variable is being multiplied by 5. So the opposite of multiplying by 5 would be to divide both sides by 5. So we're going to be implementing the division property of inequality. 5 divided by 5 is 1. So x is greater than 30 divided by 5 is 6. So what I would like you to do right now is to go ahead and take a look at the got it problems on the bottom of this page. And then go ahead and work those two out, pause the video, and then we'll come back to see if you did them correctly. All right, hopefully you were able to have some time to work through got it problems A and B, working with solving inequalities with multiplication and division using positive numbers. So as I take a look at these two, the first one, I had 4x is less than 40. So I know I was multiplying here, so the opposite of multiplication is division. So we're going to use our division property of inequality, divide both sides by 4. 4 divided by 4 leaves me with 1x. less than 40 divided by 4 would be 10. So my answer is x is less than 10. Take a look at letter B. I had 6 is greater than or equal to x divided by 7. Opposite of dividing would be to multiply, so I'm going to multiply both sides by 7. Remember to keep the 7 on top. 7 divided by 7 is 1, so x is left on the right-hand side. And then 6 times 7 is 42, so 42 is greater than or equal to x. So not too difficult there, same concept, same ideas as what it was when we were solving basic equations. When we take a look on 507, okay, this is going to be when we are working with negative numbers. Okay, so what's going to happen, we have to be careful on these because when we're multiplying or dividing by negative numbers, okay, one of the things we have to do is we have to flip or reverse that inequality sign. Okay, and so what I would recommend doing at this time is highlighting or putting a star by these words right up here. Okay, so again, if you are going to be multiplying or dividing by a negative number, we have to flip or reverse your inequality symbol. So what I mean by that is, if we start off with a sign, our inequality symbol is less than, when we're working with a negative, meaning we're dividing by a negative in this situation, instead of it being less than, it's going to become greater than, okay? Or if we start off with it being greater than, and we end up having to multiply both sides by a negative number, because it was greater than, we have to reverse it, which means it's going to be less than. Same thing applies if we have a less than or equal to or a greater than or equal to. If we start off with less than or equal to, when we reverse it, it becomes greater than or equal to. Or if we start off with greater than or equal to and we have to reverse it, then it becomes less than or equal to. So those are some things that we have to make sure that we remember and take note of. A lot of times one of the things we forget to do is the fact that we're dividing or multiplying by a negative number, and therefore we forget to flip that sign or reverse that sign. Let's take a look at example 3 here. Negative 2g is less than 10. Now if I solve this, or when I solve this inequality, I'm going to divide both sides by negative 2. Because I'm dividing by a negative number, I have to make sure that my inequality symbol is reversed. So it was a less than symbol. Because I'm dividing by negative 2, it now becomes greater than. Okay? You can see here then they've divided by negative 2, and they've changed the symbol from less than to greater than. Then when you plot it, again, we're looking at a situation of g is greater than negative 5. So it's going to be an open circle on negative 5. It's not including it. And I'm looking at numbers that are greater. So what type of numbers are greater than negative 5? My numbers to the right would be greater. Let's take a look at example 4. Okay, here we started off with x divided by negative 3 is less than or equal to negative 4. So we want to take note that we have a negative number there. In order to solve this inequality, we're going to multiply both sides by negative 3, as you can see your book did. So because we are multiplying both sides by negative 3, instead of having less than or equal to, we have to reverse that symbol, and now it becomes greater than or equal to. And negative 3 times 4 is negative 12. So x is greater than or equal to negative 12. When I go ahead and graph this one's going to be a closed circle because 12 is included because it's also equal to it, or it can be equal to it. So x is greater than or equal to negative 12, closed circle on negative 12, and it's graphed to the right. Let's go ahead and take a look at the practice problem, letter C here. And they do want us to graph this one. So I'm going to rewrite this to give me a little bit more room down here. So k divided by negative 2 is less than 9. When you take a look at this, we're taking k and dividing it by negative 2, so the opposite would be to multiply by negative 2. So I'm going to multiply both sides by negative 2. Now I have to remember I'm multiplying by a negative 2, so therefore my symbol, my inequality symbol, is going to have to be reversed. So it was less than, now it's going to become greater than. And then 9 times negative 2 is negative 18. So now I can go ahead and graph this. Okay, so k is greater than negative 18. It's not including 18, so I'm going to have an open circle on 18. And I'm looking at numbers that are greater than negative 18, and so that would be to the right. So I'm going to darken it into the right. Remember we talked about graphing the other day. When you're graphing those, make sure you make your arrow or your line that way significantly darker so we know which way that you're graphing it. Okay. What I want to do right now is to take a look at another example, and we'll use this practice number line that they have given you here. Let's say that I have a situation of negative 5x is greater than or equal to, let's say 50. Okay, so if I was to solve this inequality, the first thing I would do is find my variable. My variable is being multiplied by negative 5. So the inverse operation would be to divide both sides by negative 5. So I'm going to divide both sides by negative 5. X is left. Because I'm dividing by a negative, I have to make sure that I reverse that symbol. So it was greater than or equal to, now it becomes less than or equal to. 50 divided by negative 5 would be negative 10. So now I can go ahead and graph this. It's x is less than or equal to, and it's negative 10, so I'm going to put a closed circle on negative 10, and I'm talking about numbers that are less than, so numbers less than negative 10 would be graphed to the left. So I'm going to darken in my arrow that way. So there's another example of when we're dividing. Again, a couple things to remember. Number one, we're still solving them the same way that we did before with our positive numbers. The only difference in this situation is because we're working with negatives. So anytime you're dividing or multiplying by a negative number, we have to make sure that we reverse that symbol. If you're dividing or multiplying by a positive number, the symbol stays the same. On the top of 508, they're giving you a word problem situation where we're looking at writing a simple inequality. It says Ling earns $8 per hour working at the zoo. Write and solve an inequality that can be used to find how many hours she must work in a week to earn at least $120. So let's think about what we know. We know that she's going to earn $8 per hour. So her amount earned is 8. Do we know how many hours she's working? We do not. So we're going to use the variable x to represent her number of hours. And we know she needs to earn at least $120. So remember when I talked the other day about that table, when you're trying to fill in your symbols, your inequality symbols of less than or equal to, greater than or equal to, or less than or greater than, you may have to look back at your table if you forget your terminology. So at least means she needs to earn at least or have at least $120, but she can go over. So we're using the greater than or equal to, and then we have 120. So technically we're looking at an inequality of 8x is greater than or equal to, and we'd have $120. Okay, what I would like you to do right now is to go ahead and take a look at guided practice problems 1, 2, and 3, and go ahead and take a minute and solve those. And then when you're done solving them, come back to the video and we'll check your answers to make sure you're correct. So pause your video right now, please. All right, hopefully you went ahead and worked on questions 1, 2, and 3 on page 508. As you worked through them, we're taking a look at number 1. We should have been dividing both sides by negative 3. Because we're dividing by a negative, our inequality symbol has to be reversed. So we're going to have n is greater than or equal to 7 1/3. When we graph that, 7 1/3 would be a little bit past it. We are including it, so it's a filled in circle and darken to the right. Number 2, we're taking t divided by negative 4 is less than negative 11. So the opposite or the inverse would be to multiply both sides by negative 4. Because we're multiplying by a negative, the inequality symbol is going to be reversed. So instead of less than, it becomes greater than. T is greater than 44, open circle, graph to the right. Number 3, at a baseball game, you can get a single hot dog for $2. You have $10 to spend. Write and solve an inequality to figure out how many hot dogs we can get. So $2 times the number of hot dogs is going to be less than or equal to 10. Remember, we can't go over 10 because we only have $10 to spend. So 2x is less than or equal to 10. So therefore, I'm going to divide both sides by 2. X is less than or equal to 5. What does 5 mean? We can buy up to 5 hot dogs. We didn't change the sign because we're dividing by a positive number. Let's go ahead right now then and take a look at your website and take a look at which extra practice problems I would like you to work on.